Hello, my friends. I'm Dr. Sonali Tamankar presenting the AI A to Z series. Today we have AI for the connector. K is for knowledge graphs. A large language model is just trying to imitate what it saw during its training in a kind of monkey see, monkey do manner. They have been called stochastic parrots for this reason. Knowledge graphs are one way to give AI a hard skeleton. So let's start connecting the dots. In H is for hallucination, we talked about how AI can make up stuff. And an antidote is grounding, finding some way to anchor LLM responses in truth. Today, we will talk about knowledge graphs, which is a great way to do this. Later, we'll also discuss neurosymbolic AI, how to combine neural network approach with deterministic symbolic logic in general. We also have RAG or retrieval augmented generation. This is where LLM digs up or retrieves some relevant information from a source like a PDF you provide or also from a knowledge graph using a technique called GraphRAG. Guess what? We are looking at a knowledge graph right now. It shows these 4 episodes as entities. There is a different kind of entity, the series AI A to Z. Yet another type of entity is you, the viewer. And then entities have relationships that are shown by edges. So maybe the entity you has watched some of the episodes or subscribed to the series and so on. So a structure like this is far more precise than natural language. We have clear triplets, like there is a subject, a predicate, and an object. For example, you, the subject, watched, predicate, and episode K, object. The knowledge graph might store additional properties on both the vertices and the edges. For example, the episode H may be 6 minutes and 32 seconds long, and maybe you watched 85% of it. Knowledge graphs can distinguish between strings and things to deal with polysemy, words like bark that can have multiple meanings that we talked about before. So we simply use 2 separate entities or nodes, one for dog bark and one for tree bark. They're entirely different things that just happen to both be spelled BARK. So Wikipedia calls this disambiguation, like Mercury planet is different from Mercury, the element is different from Mercury as in mythology. So in fact, Wikidata has been described as the world's largest open access knowledge graph and has been used by virtual assistants such as Apple Siri or Amazon Alexa. There is also the Google Knowledge Graph. So when you search the name of a celebrity, this is what gives you that little box on the side showing their age, their birthday, their spouse, and so on. So knowledge graphs are everywhere. You could make one up in your head right now based on the gossip you heard yesterday, like A lost their temper with B, who is a friend of C, who is not talking to A now. That's a knowledge graph. So truly, they have been widely applied in various domains like finance and retail, and especially in healthcare, where this hard knowledge is essential because mistakes can literally be life and death. So let's talk about a few healthcare examples. UMLS is Unified Medical Language System. In healthcare, we need a meta thesaurus because there are often many ways to say the same thing, like heart attack or myocardial infarction, their corresponding ICD and SNOMED codes. So UMLS has a concept unique identifier for this, like C002705 to capture these unique concepts. They're one type of entity, these concepts, like our episodes. There are other entity types in UMLS, like chemicals or anatomy. Then there are semantic relationships between the entities. So triples like hydrocortisone affects sleep. So UMLS has been foundational in biomedical research for about 35 years. Then next we have HetioNet. So this is a heterogeneous biomedical network connecting genes, drugs, diseases, and pathways. Researchers explore questions like if a drug treats one condition through certain genes, might it also work for another disease involving those same genes? And then Spoke is scalable precision medicine open knowledge engine. It contains 27 million nodes of 21 different types and 53 million edges of 55 types downloaded from 41 databases. It is huge. It also integrates patient data from EHRs or electronic health records and links genes, drugs, and diseases to real world patient cohorts. So it has been used in applications like predicting diagnosis of multiple sclerosis with a reported accuracy of 83% 3 years before the EHR diagnosis. So knowledge graphs have been great, but they have been a little clunky to use though. So how do you create these nodes and links structure, and how do you use it? So that process needs a lot of domain and technical expertise with specialized languages like Cypher and databases like Neo4j. Now, with generative AI, we have an opportunity in both directions. LLMs can identify entities and relationships at scale and assist with building of knowledge graphs with human supervision. And they can also write code to automatically query knowledge graphs. So, knowledge graphs can help ground the LLMs and help reduce hallucinations through a technique called GraphRAG. Say we ask a complex question to an LLM: which medicines could help a patient with lung cancer and a heart condition, and how might these medicines interact? In GraphRAG, the LLM might first flag lung cancer and heart condition as entities and then traverse a knowledge graph. It might hop from lung cancer to genes, heart condition, contraindicated drugs, and it retrieves these relationships and then generates a new prompt combining your original question with this factual context. So, of course, the knowledge graph itself may be incomplete or biased, but this combination of knowledge graph and LLM has a much better shot at giving you correct and clinically meaningful answer because the LLM is grounded in hard facts from the knowledge graph. So let's do our quick conclusions. Knowledge graphs are a versatile tool to capture entities and relationships. They are ubiquitous, powering Wikipedia and social networks and healthcare research. And they can be used to ground LLMs to reduce hallucinations through tools like GraphRAG. So I hope you are enjoying the view through these A to Z windows into the world of AI. So please feel free to comment below and to connect with me, my connector friend. So see you tomorrow. L is for large language models or LLMs. Bye.